Uh, well, Lazy Chain started basically with the Celestine slots. This is a collection of like 2,500 NFTs. I think the project has been like pretty successful. We became the pretty much OG NFT for like the modular ecosystem and like one of the best communities in crypto. And one small issue though is that pretty much our success is something that has made like our collection pretty expensive. Each NFT costs like $8,000, and this is like a small issue because it limits our distribution like a lot, and it makes it much harder to grow our community. So sort of like out of this idea and the fact that we're very close to the Celeste team, Crazy Chain was born. I think now there are very little things you can do with your NFTs. Same with something like meme coins, you can just buy and sell. And I think our thesis is that communities want to see this change and want more expressivity. I think that could be pretty good and could be a pretty interesting experiment. And I think uh, yeah, we sort of to give you guys a quick rundown of our construction. We are a sovereign rollup using Get. Uh, we're using the Astria stack, and of course, we have Celestia underneath. So, uh, oh, sorry, uh, well, yeah, this is the why we're building Lazy Chain pretty much. I I think we want to establish ourselves as like the central hub for like modular chains. I think we already have the community to do this and pretty strong partnerships with Celeste and Astria. We are trying to pioneer new like methods of community engagement as well, and sort of like embed like community rewards in protocol, which I think could be pretty good. We can only do this because we are a sovereign rollup, so we don't really have validators, so we can try to pass on most of the value generated to the community, which I think gives people a pretty strong incentive to promote the chain. And yeah, we also want to like focus a lot on consumer apps and drive pretty much like mass adoption, and like like make it easy to onboard new people. And for a roadmap, we have our button, which is we're building this small lottery that is going to be like very gamified, and I think we're gonna launch pretty soon, which I think could help us like a lot in like go to market. I think in Q1, maybe early Q2, we plan to like deploy the chain, and I think we have some pretty cool distribution strategies in place already, and we're getting a lot of traction and hype. And we're probably gonna do a small eCore Legion pre-sale. We're mostly bootstrapped until now. Uh, and I mean, we have pretty solid revenues with the royalties we have from our NFTs, but we might do a small pre-sale as well. And we're also building the Sleep to Earn, which is actually one of our ideas for this Mammothon. So if any of you guys are interested in building that, definitely reach out. But Sleep to Earn is basically what it sounds like. It's like you literally go to sleep every night and you pretty much get paid in tokens, which I think could be really viral. There are some challenges of designing this, but because it's something that could become really mainstream and I think has a pretty good shot of being viral. And hopefully in Q4 we can all have dinner together in Valhalla. So yeah, this is the end for my side of the presentation, and I'll pass the torch on to Pablo for him to explain all the more technical details.
Cool. Thank you, Paco. Yeah, I would like to see on Valhalla. Yeah. Okay, I'm Pablo. Thank you for having me. I'm a technical leader on Lazy Chain. I'm a senior developer and I have been working like 15 years on software developer. And I work on different roles, project manager, senior developer, analyst, DevOps. And the last 4 years, I have been working mostly on blockchain development. So today, we are going to talk about some controversial way to implement smart contract, that is PDD and TDD. And we are going to talk about lazy chain architecture, sovereign rollup, and a little theory. I'm going to be really fast on that, and how we work on dev team lazy. So I'm going to share my screen. Okay, let me. Can you see my screen?
I can see your screen, yeah.
Cool. Let me see if I can make it bigger. No. Okay. Well, Uh, today we are going to talk about behavior-driven development and test-driven development, and we're going to apply to Solidity smart contract. The idea here is to increase collaboration between members, different members or stakeholders that normally they don't work as a whole team, and this is where came the word PTD is expressed or is potentially on that. So what is BDD? Behavior driven development. The idea is to emphasize to work or collaboration between developer, tester, and business stakeholder. And mostly the idea is that the whole uh, the whole team work as a unite. And for that, we got what we call user stories and scenarios that came to explain what we want to implement. And the normal flow is that we, someone has an idea, talk to the project owner, give this idea, the project owner talk with the CO, and after that, it came this idea of a project, for example, Sleep to Earn, and all those. And later we came to a part that we tried to talk with each others, and for that came all these user stories and scenarios in place in the middle that try to uh, put all in agreement how we are going to work with it. And and later this can be applied to those stories and scenarios can be applied to TDD. And TDD is a methodology not for doing tests and not for coverage, but it's especially applied to software development. And when you want to implement a smart contract or any other code, you can use this technical methodology, but for development, not for testing. So this idea of TTT is just a simple way to do the things. And you normally write a very small failing test at the beginning to see or to try to do the minimal implementation. And after that, the tail will fail and you will going to directly implement and fix that test. And later you can, after you make work what you want to do, to refactor a little the code. And I'm going to talk about user stories that I mentioned in the previous slide. And normally you're going to find like this. As a user, I want to do something, so I can do something. And this is typically what analysts use to express features and different scenarios and stories. And we're going to see that on this workshop to see how this can help us as developer to feel confidence on what the code we are building on. And the analysts normally use this language, which is called Gherkin language. And it has this kind of way to express these scenarios and stories in a way like express the feature, the scenario, and uses some keywords like given, when, then. Given something, when I do some action, then I expect some result. So this is mostly like we use this language on the analyst side. And here, what we do in Lazy Chain Dev, normally, like explained before, a product manager, work with the community, select most relevant needs, go to the CEO, they talk, they see the funding part, because we need to fund most of these ideas. And then with the help of analysts, technical leader, UX, all these people gather together and they start doing those user stories, documentation, and all what it required to make this implementation on the go. And yes, when this documentation is done, a project manager and a technical leader create the task and the plan that will fulfill. So basically, this is all the flow. So okay, let's go to explain first the architecture that we are going to use, and later we are going to use a simple example called lock and unlock on an NFT that is similar to the staking, but with a slight difference that you can earn points directly exactly when you just lock it. So this is the link for the GitHub project. Uh, I see if I can, or can you, Rebecca, share it on the chat, please? So if you want, you can clone it and start. So
I'm showing that.
okay, perfect. So I'm going to now share another screen. Okay, yes, I found it. Cool. Can you see this screen?
But can you zoom in?
Yeah.
So that we can read. Can you zoom in one more time?
Yeah.
Yeah, that's looking good.
Okay. Let's see if I can hide this. Oh, okay. So this is the architecture. On Lazy Chain, we want to make a sovereign rollup. Uh, there's a difference between L1 and rollups, and the idea here is to obtain certain guarantees on security side and on space size compared to L1. So on L1, we normally got a replicated node that replicate the data that it holds, and the way the transactions came into are mm, like a leader selection on the consensus. So a group of nodes select a leader, and this leader has the ability to select or order or make the order on the transaction. And on sovereign rollup, there's a different on layers that split this into three type of layer. One layer is uh, the data availability sampling, which is where all the information is stored. And in our case, we are going to use Celestia. And the difference between the L1 and Celestia is that on the other side, we got a lot of node with a lot of data replicated. And they must agree on how they gonna put on the next state of the state machine. And on difference on using Celestia is that this way of storing the data is not replicated. It's a kind of distributed and a kind of like data sharding. So the idea here is that there are nodes that they consensus each other to select what blocks of the data are going to be stored, and in a way that they guarantee that if one of the nodes are missing on the consensus, the other node can simply take that missing part, reconstruct it, and provide it. So here, the space needed is reduced dramatically. So this is why a lot of data availability sampling blockchain are rising now. The other thing that we take into account is the way that the L1 select those transaction order and how they send it to the other nodes that later they accept those sequence of transaction. And we select Astria because they provide a distributed sequencer. A distributed sequencer they agree on how this transaction are going to do or have a specific order and how they're going to be batched into in a decentralized manner. So this is principally the difference between an L1 and a stack composed by a data availability sampling and a distributed sequencer. And on top of that, there's a rollup, a lazy rollup, that is that has the execution part. And this is the flow that we are going to have on our future blockchain, lazy blockchain, that a user is going to connect to a site, and and after that, it's going to work with it by sending transactions to the rollup. And the rollup is going to be composed with a smart contract that is going to work, and that is going to work with Astria, which is a shared sequencer, and that is going to work with Celestia, a data availability sampling. So with this work, this way of working, we guarantee some things like the order of the transaction to be the most fairness, and also we want to also have to uh, to consume or allow to be consumed a lot of data with low fees. Because if you go to work with on Ethereum and you just make a simple call, it's going to charge you a lot on the fees. So we want on the future that Lazy Chain has low fees and guarantee some fairness on how the blockchain is going to be used. So this is mostly the architecture on we expect to have on our rollup. And okay, now let's go to, I hope you already download on Git clone. So we got here, at this point, you're gonna see like something like this. Can you see, okay, my screen and letters on the console?
Can you zoom in a little bit?
It's okay.
Yeah, I think that's okay. In chat, can you let us know if you'd like it zoomed in a bit more?
Okay.
I think it's good. I think that should be all good.
Okay, cool. So if you clone the repository, you will have this folders structure. So normally this is a Foundry project that has its configuration file. I'm going to minimize this a little. That will have a lot of configurations and mappings, and, uh, and that tells how to do things on using Foundry. So and besides that, we got these Git modules that we use to import most of our dependencies. So on Lazy Chain, we normally use OpenZeppelin or Soulmate as smart contract libraries for most of our development. And of course, we are going to have our source directory with all our code. Normally, we got interfaces separated from the implementations, and we got our test folder with all our tests and the script with the script to deploy things. So basically, we are going to start with like here on the README. If you follow, they say, okay, hands on to start working. So the initial idea would be to start taking tasks that the project leader and technical leader give us and start working on it. So the first one is going to be user story number one, which his story it's about to lock an NFT. Now, let me now. Okay. So the idea here on the task is it's going to follow a flow that normally, and I think it's too big. Uh, Sadly, it's too big. Well, okay, I'll try to work with this. Okay, the idea is that an analyst uh, take notes and design all these scenarios that we are going to implement. And what the analysts do is normally take a flow, normally an UML flow, and it's describe all the operation and possible path that the information can take on the code. So on on our first contract, we are going to first try to understand this flow and see what things the analysts say that we must look for. For example, the analysts define the errors that we are going to look for, the events on the smart contract using Solidity, what struct and data structure we are going to use, the variables and function. But here on this way to define things, we are going to see that it's more focused on Solidity and how to do it. And later here comes the user scenarios where you can see all these things that we talk on BDD and Gherkin language. This is Gherkin language, and I'm going to talk about how to understand this. So we got this flow here that says, okay, I'm a user. I want to just lock my NFT. So the first thing that going to ask the system is, does your NFT is on the list? Do you ownership? And if it's not, it's going to tell, no, that NFT doesn't exist. But the if that NFT exists, it's going to ask you, are you the owner? And if you're not the owner, it won't throw you an error. You're not the owner. And suppose that you are the owner and the token ID exists, that means the NFT exists, it's going to allow you to select the period. But that period could be put it in a way that it doesn't fit the system or what expect the system. So it's going to throw you invalid period. And and if it is valid, it is going to, okay, do you have fees to pay? And if the system consider to have fees, do you have fees or have you sent fees? And if not, it's going to throw you an error. And after that, it's going to execute the transaction and update the ownership, especially. So this is the first flow of a series of scenarios that we are going to analyze. So basically, what we are going to do is this that we got here. And I'm going to make it a little more faster, but the analysts give us these specifications where the whole system is going to work like a user. There will be an ERC 7021 contract that the owner owns, and it's going to store it or lock it in a staking contract, and that ownership is going to change. By the time he's going to lock it, he's going to gain points, but these points are going to be from the first beginning, at the moment that he locks the NFT. And after that, later or immediately after lock, he can exchange those points for something else. And here comes different apps or different other contracts that can do things with those points. One of them is the exchange contract. That is going to simply just consume those tokens, those points, and transform it into ERC20 token. So this is kind of staking contract, but split it in different way that you earn points and later other smart contract can plug in and use those points. And you can, in that way, lock things and later can use in different things. Like, for example, if I want another NFT token, I can consume points and earn an NFT token. I don't need to, for example, change it for an ERC20. So this way gives you more versatility on things that you're going to use or do on your smart contract. So the analysts provide us with a class diagram which defines all the mapping, address, and everything, and define those interfaces and all the errors and how the data structure is going to be. And that is represented on these scenarios that I showed you previously. So for this first workshop, we are going to try to implement this scenario, and we can, if we have time, implement this one too. And after this workshop ends, I'm going to publish all those things if you want to try it. They are different on different branches, so you can try to use TD. So let's go coding. So let's open a terminal. Yeah. And the first thing we are going to do after clone is for build. So we need to guarantee that our starting project can build. Also notice that there's a lot of other contract. This contract, previous contract already working on lazy chain and define a lot of things, like for example, this lazy 20 is our ERC20, which has already defined the constructor, and they have defining the min function to limit some things. And if we go to the lazy 7021, which is an ERC 7021, it got a lot of Open Zeppelin utilities that we leverage on, and 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 we define just simply an ARC 7021 with a certain token limitations on the token cap, and yeah, a name and a symbol that can receive from the external. And we do some sanity checks and all. So this came out of the box using previous works on lazy. And from the design perspective, we already have this, or our technical leader have already give us the interfaces implementation that is based on those user stories and all. So if you go to look for the user story, those list of events, you're going to find this event as on the user story is defined by the analyst. And here we got some strat and errors and functions, especially those that we must implement as a developer. So the first things we are going to do is start with our staking test. So if you open this staking TSOL, which is the test file, we're going to find that we got already some predefined things to work with and a setup. And some tests, they are going to use this setup, and some others we are going to define things. And if you run the test command, if we run forge test, we're going to see that a lot of tests has passed. This is the test on the ERC 7021, lazy 7021, and lazy ERC 20. And there's a lot of other tests that, for example, TSOL. And here comes my question. Oh, there's already tests for that? And let's check it out. If we go to the test over here, we are going to see that they are empty. So here comes the TDD action part. So we want to construct this. And if we go to our staking sol, we're going to find the same thing. We got the contract, we got our constructor that is empty. So this is the initial step or the setup for starting TDD. And we are going to start from the beginning. So if we go to our document here on our stories, they're going to have this one. And this one got, like I talked on previously, it has all our Gherkin scenarios. So these Gherkin scenarios are copied and pasted on every test, and we generate all the tests based on these scenarios. So on our side, as a developer, the analyst and the technical leader already prepare us this to do all things. So let's start with GTD. So here is the first task that is going to be, okay, this test goes to the constructor and it's going to test zero address sanity. So if we copy paste this, which is here's the explanation of the scenario. The NFT address is 0, so that means we haven't set up our NFT contract. So we're going to do step by step, like the analyst suggests to do this. So we're going to do given when and then, and here given I provided an NFT address set to 0. So what I can do is a simple object. This is going to be an NFT empty, so we are going to skip setup for this. Even if it's going to run, we are going to don't take care of that because we need to test the constructor. So we're going to create an empty address. And here comes when I attempt to deploy the contract, there should be an error called NFT address cannot be 0. So here we're going to, from the VM, we're going to expect this this error, and this one is going to be what is defined on the interface, and it's got to be like missing NFT address. And here we're going to use selector. And here we call our staking contract constructor. And the constructor is defined here, and it has some function, the address of the NFT, a reward rate that is going to give us how many rewards we get for every hake the blockchain generates, and what would be the fees to pay for locking and unlocking. So on this one, we are going to use to win 1 point for every block generated, and we are going to use about 0.1 ether to do this. So here we got our first TDD, and we are going to try this. So if we go to our terminal and we run our test, what's going to happen? Exactly what we expected. The test failed. So this is how TDD works. So you actually make a test to fail because there's no function provided on the constructor. And this is what we expect to. So here on this point, we're going to check for that address. So we got here the NFT address, and we are going to check if this one is address 0, which is one of the things that we wanted to do, or if we want to also add some protection here, it's not necessary, but it's nice to have, I guess. So if the address is 0 or the call length is 0 also, we're going to revert this. And we are going to throw missing NFT address. So at this point, we have just implement on the code according to this test that we provide. So now let's go to the console and run again forge test. And okay, it throws an unused on on the on the side of this. We can for now just for avoid the error that we are going to use it, but we are going to find it later. So just the error doesn't appear because we got a strict on checking things that they are not. So I ran this and now the test passed. So this is how TDD works, and you are implementing the minimal needed to pass this test. So now we're going to do the second one here. And this is going to be invalid reward rate. So the analyst already told me what is the scenario and what do I need to do and check. So I'm going to write this. And given I set a reward rate less than or equal to 0, look that here the reward rate is defined as uint and signet, so it cannot be 0. And why it's asking? Because the analyst side create a model that can be applied to any coding language, not just Solidity. So this Gherkin language doesn't know which language you're going to use to implement. So it got to be sure some things that work with it. So in our case on Solidity, defining on the input that is unsigned int, we guarantee that that will not take a negative value. And the only thing that we need to check is equal 0. Why equals 0? Because if the reward is 0, the user is going to stay and win nothing. So yeah, he's going to be pissed off. So here on this reward rate, what we are going to do is just first we already checked this on the previous stage. So in this one we are going to just check that. And here what we need to is to create an NFT, because here the invalid reward that we already did. Okay. We got this function that only check the missing address, and we now need to check for the invalid rate. So here I'm going to spec and revert. And I'm going to use the interface. And here is going to be invalid reward rate. Select. So I'm expected to this one, drop that error. I'm going to call the contract for creating this. So I'm going to take staking. Staking constructor. In this case, since we already are checking for missing NFT as the first step, I want to avoid this. So I'm going to need to create here as a precondition an NFT token. So here I'm going to use the setup definition, and I'm going to use a new lazy because since it's a constructor, I need to ensure that everything is correct. I'm going to call this lazy NFT, and going to be its name lazy, and token cap would be 4, and going to be first, I don't know, lazy hash, something like that. Going to have this. I'm going. So now I can ensure that this is not an address 0. I can create it as an address different than 0, but I want to start using my lazy NFT contract. So in this case, I'm going to stake this one. It's going to be address. I'm going to test what is invalid reward. So I'm going to put 0 because this is what we want. And I'm going just to make sure everything is working. Just pay the fees. Or actually not pay the fees, define this. So here, so here, selector is taken. Okay. So, okay, now I finish this test. Let's run it. And of course, it's going to fail because on the other side, invalid URI. Wait, here's an unexpected error. Is complaining about this. Okay, there's something on this that is not thrown by it's thrown by the lazy NFT that doesn't like this. I'm going to. I think it has to do with. Yeah, I think it should be here. IPFS. That one. No, it should be okay. Let's check that. So here, there's a validation. And the validation, look for this. And after that, the path. So let's check if that's okay. Maybe I'm missing something. No, it's okay. This should be a hash. Let's run it again. Okay, there was something, I didn't catch it, but okay, it failed because it's back to revert now. So this validation on the token side goes well, but now it says I expect that this failed with invalid reward rate, but actually that would not happen. So I'm going to decode the constructor, and now I add another restriction or sanity. So here I'm going to ask for reward rate is going to be equals 0. And if it does, I'm going to revert it with invalid reward rate. Let me check. Yeah, okay. And after that, I'm going to run it again. And the test path. So I actually implement the last one here, which is another constructor parameters, and now it asks for successfully initialization. So I'm going to have all these things that I need to take into account. Looked at as a developer, what I'm only doing is just follow the logic that the analyst and the team works on it, and I'm just simply implementing what the scenario set, and I'm checking it. So the first one is given I provide the valid NFT. I'm going to copy paste this one. I provide an NFT that is valid, and I set the reward greater than 0. I can do it on the constructor when I pass it, and the fees greater than the equal. When I deploy the contract with this parameter, the contract should deploy successfully. So at this point, I'm going to do the staking equals, I'm going to call it new staking to differentiate from the setup. And what I'm going to do, this one, staking, call the constructor, and I'm going to pass this address of the LNFT, and I'm going to provide a valid reward rate that's going to be 1, different from 0. And I'm going to put as fees that value. And after this point, it says, okay, once you got the constructor implemented successfully and the smart contract deployed, then I need to do some extra validation to be sure that that is. So the NFT address should be set correctly. Right? So I'm going to do an assert here that is going to be this. In this case, I can provide a way to call this, call the new staking, and call, I don't know if it has its interface. At this point, we don't have the interface exposed. So what I can only do on this point is just check that the NFT is just created. And I can do that different on even on the previous step. So I can do this like this to ensure this one. I can do it here, and I can ensure that this is not going to happen. And later I can implement here the getter method to access those. And the reward right here, I can do like assert, and this is the new contract. And here I got access to this one because it's defined, and it should be greater than 0. And here I can do the same as, in this case is fees, and it should be greater than 0. Or check it as equals to this value. So until this point, there's something red. Let me check. Okay, it's just, so at this point I think my test and implementation from the test side is done. So let's test it, and okay, there's something on the code wrong. So undeclare identify, okay. I forgot to declare this one as staking. And let's try it again. Okay, and this panic because we haven't finished our implementation. So the assertion field here with a panic, I can do, for example, I can use for test, and if you go to the README, you will find at the end some tricks. For example, if I want to run only a test, I can use this trick. And I can see what here is failing. This is this taking test. This is the name of the class that is defined on the class. And the test I want to test is the one which is failing, because I need to trace to be sure what is failing. So in this case, this is the name of the test. Okay. Let's try to see. And one of the good things about Solidity and Foundry, it can actually show you step by step what you are doing. So here is this taking test constructor. It calls the new one. And one of the things is it execute the staking reward rate. And when it says, okay, some assertions are failing, so there must be something here for the fees. And probably this one. So let's check it again. We did it with one, and we call it the reward rate. So I guess there must be something that I'm missing. On the assertion fail. So let's go check what is implemented. If we actually implement here the check for reward rate, so there must be something else that is missing here. So let's check it out. I got the address, the reward rate, fees. I didn't set up the fees, and nor the reward rate. Okay, so I'm going to remove this. I'm going to set up reward rate equals reward rate. I'm going to set up the NFT address because I already checked it here. NFT address. And since I already set up the fees, I'm going to set up the fees also. Okay, now as expected this failed, and it was because I didn't set up. And that's how TDD works. So actually the error was okay and was verified by analyzing the stack trace that it was. Now let's run it again. Since we implement those things, we're going to track to see the error. Okay, fails again. So there must be something else that is failing. Okay, it checked the reward rate, it checked the fees. So let's check what else is asserting. Maybe there's something else that is missing here. So there's something on the assertion that doesn't like it. So what I can do is, okay, let's see. This one is the reward rate, and the fees should be 0 and are greater than 1. And the NFT address is that. Yes.
Pablo, we do need to wrap
Time.
soon
Okay.
and move on to catch your
Okay.
work.
I'm going to wrap up a little, but yeah, the idea here is that you use TTT and look for the errors and tracing and try to implement and fix all the code until it works. So this is a methodology that you can use to do smart contract, to implement smart contract. And yeah, that's all. Thank you. I'm sorry for the last moment, and yeah, I extended too much. Sorry.
That's okay. We'll move straight into the capture workshop. So I'm going to invite Geordie to the stage and Nitya, and I'm going to move Pablo and Paco backstage again. So in response to some of the questions that we've had in chat, all the workshops are being recorded and they will be uploaded tomorrow to the Discord, the Hacker Pack, and also you'll get them in an email. So it'll be very easy to rewatch them and use them throughout the hackathon. Okay, I'll let you guys get started and I'll go off stage.
All right, testing. I want to make sure everyone can hear. Great. So I'm Nitya. It's my colleague Geordie. We're going to be here talking about Capsule. And so if you have any questions throughout the presentation, feel free to drop them in the chat and we'll have a look and get to those as well. So I'll quickly share my screen. All right, great. So Capsule is a wallet and authentication suite for crypto applications. So we really make it easy for application developers to onboard new users into their apps using a variety of different SDKs and components to do things like social logins, phone number-based auth, etc. So just to maybe start off, why is wallet UX important? And why is this unique in crypto? So in Web 2, let's say I go onto Twitter to talk about this workshop, I might draft my tweet, hit post, and then that entire feedback loop of me thinking about what I want to tweet, me verifying that there aren't any typos, hitting post, that getting reflected in Twitter's database, and then everyone seeing it, that all happens in one app. But in crypto, there are two different applications that participate in this process. Let's say that I wanted to send to get a quote from an AMM. The first thing that I would do is go to a DApp, type in some information about what tokens I'm swapping, but then to actually execute that swap, I need a wallet. So the reason that this is such a fundamental part of UX is that in any Web 2 app, I can do exactly what I want to in a single application, but in Web 3, I need to switch back and forth between the DApp I'm using and the wallet that my funds and my identity, et cetera, are associated with. Embedded wallets are a special type of wallet infrastructure that fixes this. So embedded wallets make it possible to create new wallets and actually execute those transactions all within the confines of a given app. So users don't have to leave to download another standalone wallet. They don't have to switch back and forth, deal with pop-ups, things like that. And this is really what Capsule does. So as mentioned, the challenges for apps, there's a few. So the first challenge is that kind of rolling one's own wallet. A lot of Web3 users aren't always going to be that cognizant about how they're storing their private key information. Some people might have seen a meme about a seed phrase on a Post-it stuck on a refrigerator. There's all kinds of ways that that Web3 seed phrases are different from a password, and therefore a lot of the best practices for storing a password don't really apply. The second is onboarding UX. So if I'm trying an application on a new chain and I don't yet have a wallet, before I buy the NFT that I was excited about or make a post on the new social on a new social app, I need to first download a wallet, secure my seed phrase. Sometimes I have to download a whole new extension or mobile app, and then I can get back to what I wanted to do in the first place. And the third is signing UX. So as I mentioned, before I actually want to execute any transaction, I need to review that in my wallet and switch back and forth between my app and my wallet. So the wallets have come a really long way. So we started with browser extension wallets like MetaMask, like all of the browser wallets we know and love. Then we had a variety of mobile wallets. Some of the mobile wallets integrated more functionality. So this is when we started getting integrated swaps, maybe something like purchasing a name through a wallet. And then kind of a third era of embedded wallets. So as I mentioned, embedded wallets condense this together and allow you to really go through that process of creating a wallet and onboarding to an app at once. However, most embedded wallets are actually app specific. So what this means is that if I want to use 5 different applications that have embedded wallets, now I have to create 5 different empty wallets. And this is, of course, a challenge because what's so wonderful about things being on chain is that all the assets are interoperable, all the data is interoperable. If now everything's stuck in an embedded wallet in just one app, my NFTs in one place, my tokens are in another, it's a bit frustrating. And so what we've done with Capsule is make embedded wallets work interoperably across applications as well. So we get the same benefit of not having to download an extension, not managing a seed phrase, not downloading a mobile app, and the same wallet is accessible across apps. So that NFT that I earned in a game, I can connect to another application that's an NFT marketplace and go ahead and sell that right away without ever downloading another wallet. And so really what cross-app embedded wallets are the best of Web 2. So this is easy onboarding, transaction signing without pop-ups, and then the best of Web 3, portability, so a full interop across the different apps, as well as security. So I still own my keys, the system is still non-custodial, and I get all these benefits. So what we do on the EasyUX front is, one, we allow you to easily bring users on chain. So this modal is completely configurable. You can go to demo.usecapsule.com and kind of configure this to your heart's desire. And then we also allow email, phone number, or social-based logins to actually create wallets. And then on the Web3 side, a little bit on how Capsule works, and we can kind of answer any questions to go deeper here. But at a high level, we use a non-custodial MPC or multi-party computation system that leverages distributed key generation and signing. So what this means is that only the user can sign transactions, so it's a fully non-custodial system. In addition to that, the private key is never all held in one place unless the user wants to export it. And so this has a lot of great security benefits that if anyone's interested, I can go into further. Second, we have passkeys. So the passkey is how a user authenticates their account. And then third is transaction security. So apps actually get scoped access to the wallet. So let's say I connect my wallet to 5 different apps. If one of those apps gets hacked the next day, my funds are safe. And now I'll go through some key features. So the first is social logins, as I mentioned, letting people onboard to applications the way that they're used to. The second is multi-device and recoverable wallets. So let's say I lose my phone, there's still a way for me to get my wallet. And then the third is cross-application composability. We go a level deeper here with permissions as well, which is what I alluded to earlier, where I can allow each application to have slightly different access to my wallet, depending on my preferences as a user. So now just talking through the hackathon and some of the things that we're excited to support. So Capsule has SDKs across a range of different platforms. We have React and a variety of different web SDKs, so including things like Vue, Svelte. We also have a server SDK. The server SDK allows you to sign transactions and generate wallets fully invisibly in the background. Third, we have a variety of different mobile SDKs across React Native, Flutter, and Swift. And then fourth, we have wallet pre-generation. Wallet pre-generation is a special kind of onboarding where you can actually reserve a wallet for a user before they even sign in. An example of when you might want to use a pre-generated wallet is, let's say I want to pre-register wallets for 100 VIP users of my app. And then when they log in, I want them to already have an NFT. Pre-generated wallets let us create a wallet for a user before they've even signed in. And then once they sign in, they can claim it. For the Celestia Mammothon, we have a couple of different ideas that we're excited about. And so the first is an arcade game, eventually maybe even an arcade, a full-on studio. So the first here is really using the pre-generated wallets to let users play a game. And what we can do here is the transactions to play the game can be fully on-chain. But because they're pre-generated wallets, the user doesn't have to sign up. So they can land directly into onto a web page, see maybe Snake or Tetris or Minesweeper. But then as soon as they've completed their first game, you could prompt the user to actually then onboard, set up their wallet with an email, phone number, etc. So that's one game we're excited about. On the interoperability front, another idea here is you could consider giving users an asset that can be used in another game. So maybe you want to turn this one game, so let's say it's Snake, into a full-on arcade. And so in this case, maybe you want to create a point system. Maybe you want to have a couple of different apps in different places that all leverage this. Or maybe you want to use an asset that's accessible in an existing project. So maybe you want to use referring to the folks who went before us, maybe you want to use slots in some way in your project and leverage that interoperability. The second idea here is a Telegram trading bot. So, and I should mention here that we also have, Jordi will be going through this in more detail, but we also have full Telegram bot support as well. So this idea is really a mini app or a bot that takes some goals of, let's say, we want this bot to try to acquire a certain NFT, or we want them to acquire some certain tokens, and take some goals or prompts and spins up an AI agent. And so you can initially use the Capsule pre-generated wallets for the AI to trade. And then once the AI meets a goal, you can allow the right user to claim their wallet. There's some interesting kind of ideas here as well with this right user portion. For example, let's say I want to give my friend a gift. I could reserve this AI agent in their name, and then whenever they'd like, all they have to do is verify that they own the right email or phone number, and they can go ahead and claim that wallet. So moving next from here, we have a few different ways to get started. These are a few QR codes. So the recommendation is to set up a developer portal account where you can get an API key, and then you can use that API key along with all of the docs and examples that Jordi will be going through to get your app up and running. And if you're just curious and would like to learn more, you can visit the website on the second QR code. All right, that's all for me. And if anyone does have questions, you can go ahead and contact me through either of these channels. Thanks so much.
Awesome. Thank you so much, Nietzsche. I'll be taking over here. Hey, everybody. My name is Jordi. I head up DevX and integrations at Capsule. I'm going to do a quick walkthrough on how you can quickly get started utilizing Capsule. I'm going to quickly share my screen here. Hopefully, everybody can see that. Can you see that, Nietzsche? Everything good?
Yep.
Awesome. Cool. So obviously, like most places as a developer, you're going to start out on our docs. Our docs is comprehensive. It gives you a quick setup for all of our different frameworks and SDKs that Nietzsche already mentioned. To start off with, you can just go through here. You can learn a little bit more about our core concepts, learn about different integrations like the Telegram bots that Nietzsche just mentioned a second ago, and several customizations that you can do with our Capsule model. And I'll be going through those pretty soon here. But to start off with, you're going to need an API key. And to get an API key, you're going to need a developer portal, which you can quickly find at the top here, left-hand corner of our docs. That'll take you over to our developer portal. I'm already logged into our account, but normally you're going to actually have to log in via our modal. Once inside of here, you'll create a project. I already have a project for beta development. You'll click that project. You're going to be able to generate API keys for beta development for your project. I know, I think Mohammed Javier asked about this already in the chat, so you can get a quick look. So I'm going to go to my existing key here. Since we are in Celestia, I'm actually going to scroll all the way down to the bottom to see our supported wallet types. Right now I have Cosmos enabled. You can, since we do cross-app embedded wallets, obviously, as you mentioned, we do EVM, we do Solana as well. But since we're in the Cosmos space right now, I'm actually going to change this. Cosmos already enabled, and I'm going to set this to Celestia. And you'll see why I'm doing this in a moment. It's going to affect the returned wallet that gets sent back to the modal. And you can have the correct prefix for your Cosmos addresses. So I'm going to save that really quick. And then from there, I'm going to head on over to our starter templates. Now, we provide you with a set of starter templates for various frameworks that you can quickly get started if you're starting a new project and you just want to test. These starter templates are very minimal. They give you the very base out of the box necessary stuff that you need to get started with Capsule. So if I go in here, you can see that you already have a very basic Capsule implementation. And I'm actually going to walk you through just doing that really quickly manually. So I'm going to tab back over here. This is actually the clone version of that React V application already ready to go. And we can now start integrating Capsule. Now, to start Capsule, you obviously have your API key. You got to specify your environment, and you create an instance of the Capsule class. But I'm actually going to do something really cool. What you can do is go back to the docs, and you can copy paste it. If you went down here to React and React V, you can copy paste some of the information here. But I also want to show you guys that you can actually use this search tool as kind of like a little like chat box and quickly ask a question, right? So I'm going to ask it, how do I create a Capsule instance in React Vite? Oops. Let's see what it gives us. And as you can see it outlined already, you have to create a Capsule client instance with our imports and everything ready to go. I'm going to grab that really quick, and we're going to paste that inside of here. And I'm actually going to just change this to Capsule client. My personal preference, but of course you can do whatever you want. Now that we have that, let's head on over to our app. I already have a very basic template, just a minimal UI, just a box, and all of our imports that you're going to be needing to start working with the Capsule modal. After this, I'm actually going to show you how to do Capsule pre-generated wallets as well. But starting off with the modal, obviously you just need an instance of our modal. Your OAuth methods, these are your social logins that you want to utilize, Facebook, Google, Twitter. I know somebody in the chat mentioned Telegram. Yes, that's also a choice that you will have available to you. And then from there, a few more imports that you'll need. Obviously, state management. We want to know if the modal is opened and or closed. And then that Capsule client instance that we all already created. Since this is actually a named export, I'm going to go back out here and set that to export. So it's a named export. All right, now we're good to go. So to start off with, you're obviously going to need a state. I'm going to say is modal open, just a basic state. Thank you, Copilot, there for filling that out for me really quick. And then, putting them in the wrong spot. Return, there we go. Awesome. And now we're actually going to need a few things, right? We need a button in order to be able to open that modal, and it's going to automatically fill us in with our state action there. And then next, we are going to need the actual Capsule modal. For that, I can write it out manually, or you can actually just use the demo that Misia mentioned earlier at demo.usecapsule.com. I'm going to walk over here, use demo.usecapsule.com. In case you forget about it, it's right here as Modal Designer as well, and that's going to open it up. This can give you a quick little tool that allows you to kind of customize your own modal instance. You can brand it to your brand, to your application, so really it makes it part of your application and feel like it's part of your application for your users. You can fully customize what you see inside of the modal, configure the Web 2.0 settings here. You can add additional Web 2.0 authentication methods. You can disable email and phone if you only want those OAuth methods. And even going down further, we actually offer external wallets as well. So you can enable wallets for different ecosystems, for Cosmos, for EVM, for Solana. In the Cosmos ecosystem, you can see down here, you have Kepler, you have Lipa as well. For this demonstration, I'm just going to stick to social logins right now. So I'm actually going to label Web 3.0. And then you're just going to be left with just the social logins we have enabled. You can actually reorder them if you want them to appear in a different order. And a really cool thing is you can actually collapse that UI really quick so that you can get a kind of slightly different view. Maybe if you did have the Web 3.0 enabled, you want to show all those wallets, but all the social logins are closed off. So I'm going to actually now I'm going to re-enable email and phone as well. I'm going to keep that under expanded. And this looks fine. We're going to change this. But what you can then do is go over here to this code tab, and it's going to give us an instance of that capsule that's already configured to what we want it to look like. And then we're going to go back, drop that inside there. We now have an instance of capsule. Now we are throwing a little TypeScript error here. That's just because we are in TypeScript. And I'm going to change that over to, I'm going to grab all of the OAuth methods. I'm just say object values.oauth method. And now that's just going to fill that array with all the available OAuth methods. But you're going to see that you have Google, you have Twitter, you have Apple, Facebook, and a lot of the most popular authentication methods overall. Now that we have this, we have our state, we have our button to trigger our on click. Very simple, straightforward. We can actually now go back and head on over. It's probably localhost 5173. We have an instance of the capsule. We click open, and ta-da, you have a capsule modal, the login, and everything. And then I'm actually going to go back to our demo just to show you really quick. Let's actually change this. I'm going to want something a little nicer. I like the really like space mono typeface. I'm going to make it all non-rounded. And I'm going to grab that code again. And what you can see is it updated to include a font and that border radius into our theme style. And you can obviously include your logo. If I added my logo inside here in the URL to a logo, all of this would update. You can then just drop that into your application. But for now, we're just going to keep this pretty simple. So I'm going to grab that again, replace the existing version of capsule modal. And because it's given us the old ones, we're just going to do that object.values OAuth method one more time. And I actually do have a logo already imported into the project, so I'll just replace that there as well. Fonts will always grab fonts that are already imported into your application. So just make sure whatever font you want to utilize that's specific to your app is already imported, and then pass that string inside here. We're going to use your application's font for the modal. Super cool. So now that we have that, it should already hot reload. We go back, we can see that we no longer have the rounded edges. We are using a different font type. We're using that space mono type. Super cool. Now let me just show you and demonstrate you an actual usage of capsule. I'm going to log in here using my email, and I already have an existing account. So normally it would go through the create wallet process, but since this is just my existing beta account, it's going to pop up that passkey on the capsule portal. I'm going to authenticate using my device's passkey. It's going to give you a series of wallets. And what you'll notice really quickly is that we only had Cosmos enabled, and the wallet options all say Celestia, right? So we already are configured. Capsule is going to return back to my application, Celestia wallets. So we're good to go. So we can grab one, we can whatever we want, depending on your application. It will say your application's name. This is all configurable inside of your developer portal for your project. So I'm going to connect that wallet. It's waiting for that passkey. And now we're connected. There is our wallet. We're good to go. Now, obviously, we don't have a reactive state in right now to tell us that we're actually connected. But if I reopen that modal, it shows us that we're connected. And you can see all the on-ramping configurations that you enabled inside of the developer portal. You can see that wallet address that you're currently connected to. And that's a good starting point for your application. A very simple, streamlined way to get started with authentication. Now, moving past authentication, we can go into something that Mitya just mentioned, which was pre-generated wallets, right? We can grab an identifier, whatever that identifier is, whether it's for a Twitter account, a Telegram, maybe it's a random UUID that you utilize in your application to identify your user. And we're going to create a wallet for that user. Now, at the time of creation, that wallet actually does not belong to the user. It's fully controlled and managed by the application itself, up until a further point where you, the application developer, decides that user can now claim it. Once claimed, the user has full control of that wallet. It's now protected by their passkey, and they have to go through the normal authentication flows. Up until that moment, you, the application, control that pre-generated wallet. You get to sign with it and do what you need to do, which also means you can actually utilize this on the server to do some really cool server-side signing type stuff. You can do Telegram bots, you can do games, as Nitya mentioned. You can even do things like AI agents and things like that, sign and do automated trading on behalf of the user. So really quickly, I'm just going to show you how you can go about creating a pre-generated wallet. I'm actually going to strip this out since we no longer need the modal. You don't actually need to change the client. The client remains the same. The client is where you do everything with Capsule and all of our features. If you look through our docs, almost always they're going to start with, do you have a Capsule client instance that's already configured and ready to go? I'm actually going to remove this state. Now, pre-generated wallets doesn't actually need state. It does not need UI. It's all programmatic. But for instance, we're doing this example, and just to show you, we'll create a little UI to go alongside of it. So to start off with, we're going to need a state. I'm going to say wallet data. And we're going to set wallet data. From there, oops, use state. And I'm just going to make an object. I'm going to assign a pre-gen ID. We're going to fill that in with a random UUID. And then we're going to have a resulting address that comes from that creation of that pre-generated wallet. I'm actually also going to grab the wallet ID once we got that, because we're going to need that in a little bit in order to do signing. And then after that, the user share. Now, the user share is a very important part of the pre-generated wallet, right? Since as Nizia mentioned, we're a 2 of 2 MPC, which results in having 2 halves of share for the keys. We have 1, you end up with 1. Now, normally the user ends up with 1, but since you're using pre-generated wallets, right now the application has 1. And it's very important to save this for future usage, right? You're going to want to be able to sign transactions at some point in the future, but that's a good starting point right now. Now let's create a function that will allow us to create that pre-generated wallet. So we're going to create pre-gen wallet. Thank you, filled it in right there for us. And now we're going to do const pre-gen ID. We're going to just generate a random UUID that we can utilize. From there, we're going to do a pre-gen wallets. And for that, again, we use the capsule client. It's a very simple call, a 1 method call. It actually already partially filled it in. It tried to guess, but it's not correct. It's actually create pre-gen wallet per type. And it's per type because you can pass in an array of the types of wallets that you want to create. So again, if you want to create EVM, Cosmos, and Solana simultaneously, you're able to do that. For our demonstrations, we'll just stick to just Cosmos for now. So we're going to now pass in that pre-gen ID as our identifier. We're also going to then specify the pre-generation type. So you have custom ID, email, or phone. If you want, if you have a database already of existing users, their emails, you can just grab that whole set of emails and generate a pre-generated wallet for each one of those existing emails. Same thing with those phone numbers. You just have to pass in the pre-gen type here. But we're going to use custom ID since we're using a random UUID. And the very last thing you're going to pass in here is going to be an array of the wallet types. So we're just going to grab the wallet type, and we're going to specify Cosmos since we're in the Cosmos space and ecosystem. Cool. Now that we have that, the next step from there is that's going to return an array of wallets. So if you actually asked that you were trying to do multiple different types of wallets, you would get a full array, but we're just going to have an array of just one single object for a wallet. So we're going to go address, and we're going to say pre-gen wallets. Oh, it does it for us. Awesome. And it's possibly null. We'll just say that to help us out. And then similarly, we want to also grab that wallet ID. And it's not actually wallet ID, it's just ID. Great. And then from there, like I mentioned before, the most important thing you want to immediately grab after creating a user wallet is to grab that pre-gen user share, right? You're going to want to, it's a relatively large base64 string. You're going to want to grab that, store that, because you're going to have to use that later on. As long as that wallet remains unclaimed, you need to store, hold on to that user share. Once the user claims it, we do rotate those keys. So now that you don't have access, the user now manages that fully. But so we're gonna now grab that pre-gen user share, and all we have to do is capsule client get user share right there. Cool. Now we have that user share. Cool. Now that we have all that information, thank you, Copilot again. We can just fill that in, set all that data. Cool. And then user share could possibly be null. So let's just set that like that. Awesome. And then to finish this out, let's get again, you don't need an UI for PG. You could do this. You can call our server SDK and do this exact same function completely 100% on the server, 0 UI. But just for demonstration purposes, we're going to actually do it here on with a UI, create pre-gen wallet. Thank you. And then we're just going to do a simple div inside of that. Maybe it'll fill it in for us. It does. Awesome. Save us some time there. Cool. And I am likely missing there we go. Awesome. So now that we have a fill function, let's now head on back to our application here, you can see we start off with an empty state. We have our create pregen wallet function. I'm going to click that and boom. We have now created a pregen wallet based off of this random pregen ID. We have a address. This is actually, it's the Ethereum address. It's the same public key though. We can adjust that really quick for a new pregen wallet by just changing to address secondary. And that's going to give you the Cosmos address. So we're going to save that. We're going to refresh that really quick. Let's create a new pregen wallet based off a new random ID. And that's currently set to, now you have that Cosmos address. And then the user share, big giant base64 string that you're going to want to save in the wallet ID. But this is really cool. You can take your user IDs or how you identify users inside of your application, create an associated wallet for that user, and now be able to do things on behalf of the user. From there, the next step obviously is now that you can authenticate via our modal, you can have a pre-generated wallet. The most important thing I think that most people want to do with the wallet after that is sign a transaction, right? So let's try to do that really quick. We can create a basic sign transaction. And we're not actually going to sign an actual transaction. We don't have funds right now, but I'm going to just demonstrate what functions you would need to call. Again, as mentioned earlier before, the capsule client is where everything happens automatically for you. So the capsule client itself provides several methods on it. And if we were to look at them, we can do that. You have sign transaction as one option. You have sign message as another option. And then you have send transaction as your third option. Now, send transaction, pretty straightforward. It will, once you sign, it signs it under the hood, sends it automatically. Sign transaction, this actually requires a RLP encoded base64 string so it's primarily utilized more so on the EVM side of things. In most instances, when you're doing everything in signing transactions manually, you're going to want to use the sign message. Sign message signs on the raw bytes. So you can pass in anything that you want to it, any type of message, any type of transaction, and it will automatically sign on that. So pretty straightforward. Sign message is what we're going to utilize. Since we do need a few properties in there, it's telling us we need the wallet ID, which is why we started earlier. We also need the actual message that we want to sign on. So I'm going to just create a message. And for this, since you have to encode it, let's just encode it, BTOA, and we are going to say hello. Did I spell that correct? Yeah. Hello, Mammothon. Awesome. There's our message, and where we encode that. And now what we could do over here is pass that the wallet ID in, which we have started inside of wallet data, and then our message. And that's really all you need. From there, you can do whatever you want. This will obviously return the signed message in the transaction. Because it's just signing and it's not actually sending it, it's actually up to you to now send that message. And I could show you how you can do that possibly if we have enough time. But let me just put this as a signature. And we're going to wait that because it is asynchronous. And what's going to happen is going to send that out to Capsule. Again, we're MPC, 2 of 2 MPC. There's going to be some back and forth that happens behind the scene, and we're going to end up with a transaction based off the user shares. But that's pretty straightforward. Now, we obviously need something to trigger this. Let's add another button inside of here to sign that transaction. And then let's also add another field for our, yep, it had it right, for our signature. Paragraph doesn't want to do okay. Now since I'm not actually storing this yet, this is where it normally would go. I'm not storing it, so maybe we shouldn't do that. We can just console log it. I don't want to add another state just for sake of time here. I'm going to remove that, but we can still trigger the function with our button, and then we'll take a look at the logs and see what happens. Let's go back. Let's inspect our logs here. And let's start fresh. Create a new pre-generated wallet. Cool. And there's our signature. These are not related to us. But yeah, there's our signature. You get back our signature object relatively quickly, and that's using our pre-generated wallet that's completely local to my device. It's local to my application, specific to my application, and I can now sign transactions. If I wanted to, I can now take this user share, I could copy paste that, I could send it to my server, and now my server can start also doing all these types of signatures as well. Now, where these can be utilized is all over. I think one of the popular cases that Nitya already mentioned was actually inside of a Telegram bot. Telegram bots, just because they're server side, and also Telegram web apps, which is a very new thing that's very popular. Telegram web apps. You can create little mini apps inside of Telegram that give you a little quick UI. And I'm going to show you what that looks like, actually. So I'm going to pull over my Telegram. Hope you guys can still see all of that. And this is already made. We can share those links. You can actually find this inside of our examples hub. And I'm going to launch this. And this is a Telegram mini app. What it's doing behind the scene is I already have an existing pre-generated wallet inside of Telegram for my Telegram user account. And it's stored inside of this user, my user's Telegram cloud storage. So it is completely custodial to me. When I'm logged in, this mini app can actually grab those user shares that are inside of my cloud storage. So you can see my user, my Telegram user information, my username, and everything else. And there's the wallet that already exists for me, right? So I can actually backtrack out of here. I'm going to clear that storage. And the app is going to restart now. I don't actually have nothing's inside of the Telegram storage, so it's not actually, it thinks I don't have a wallet. We're going to create a pre-gen wallet. And this is doing the exact same thing that I just demonstrated inside of the React Feed application, right? It's generating a pre-gen wallet behind the scenes. Now, in this instance, it does take a little bit longer just because there's a storage requirement for Telegram web apps where you have to split it up, that big old base 64 string, split it up to be able to store it appropriately inside of the capsule. Oh, sorry, not the capsule, but the Telegram cloud storage, pardon me. But once it's stored inside of that, you'll have a pre-generated wallet. And from there, you can do everything that you were doing basically on the web. Let's see if it actually is able to finish. Sometimes it's varying times. Let's speed up. Anyways, we'll just move past that if it's taking a little bit too long. But yeah, it's the exact same process that you basically saw before. It creates that pre-gen, stores it for the user. You can do that on their behalf, just grabbing basically their username, and you can create that as the identifier, and then you can go from there. We will provide these links. I think they might actually already be present inside of the cohort, and you could do whatever you need to do. But yeah, that's getting up and running with Capsule in just a few minutes using two different methods, I guess, for our SDK.
Thank you very much, Geordie and Nitya, for the introduction to Capsule and a guide on getting started. To answer a lot of the questions Nitya has already got to, but in terms of recording and links, we will share those with you so that you know you have everything you need to get started. Thank you everyone for being so active in the chat and asking questions. I hope that you're all in a position now and you feel that you can get started building the Capsule idea, but don't start yet because the Mammothon doesn't launch until the 1st of February. So come back to some other workshops, have a look and see if there are any other projects you're interested in. But hopefully lots of you will be building towards the Capsule ideas, and we're going to see some really cool stuff coming out from you guys. Geordie, do you have a contact that people can use during the Mammothon with any questions, any technical questions?
Yeah, I mean, you contact Nitya. It's probably easier to contact Nitya first and then go from there. And then I usually come in once you're starting to actually do your integrations and everything over thereafter, but she can definitely get you up and started. She'll probably drop that real quick. Somebody asked in terms of sending transactions, reporting IBC. Yes, 100%. So like we have a wrapper around Cosm.js. We actually employ wrappers around very popular Web3 libraries. Ethers over, Ethers VM over on the EVM side of things, Solana Web3. So our wallet will do all the signing underneath the hood, but all you have to do is create a Stargate client with our signer built into it, and you can start signing using Cosm.js exactly how you're already accustomed to signing. You can find that on our docs. You just have to search Cosm.js, and you should be able to get up and going there. But yeah, sorry, Nitya can plug in their contact information there.
Yeah, absolutely. Another thing that we might do, maybe pending, I'll check in with Rebecca, is we could also set up just a group with everybody who's doing capsule hacking around the Mammothon. So maybe look out for more info on that.
Yeah, there will be a technical channel in the Discord as well that will onboard some Capsule mentors too that you can tag and ask questions in as well. So that's another way to get in contact with the team. Okay, so we'll wrap it up there for today. This is the first 2 Mammothon tutorials out of our 10 days of tutorials and then our launch. So I hope you all felt that today was very useful, and I hope that you come to some other sessions if there are other ideas that you're interested in building for. Otherwise, I will let you get on with the rest of your days, and I will see you all tomorrow. Thank you again to the Capsule team and to the Lazy Chain team who've possibly left by now to carry on with their days. But yeah, thank you everyone, and we'll see a lot of you again another day this week.
Thank you so much, Rebecca. Appreciate it.
Thank you.